Welcome to our webinar on Introduction to Metadata for Research Data Management, a Data Documentation Initiative Perspective. The webinar is a collaboration between the DDI Alliance and CoData, and is the first in a series of webinars on topics related to the DDI family of metadata standards and their use. We are very happy to have so many of you with us here today. Before we start, some housekeeping rules. The webinar will consist of a presentation followed by a question and answer session. When entering the tool, you will be muted by default and your camera will be turned off. Please enter your questions in the question and answer tool during the presentation or after during the question and answer session. At the question and answer session, a selection of the incoming questions will be addressed. If your question requires further clarification, you will be asked by the moderator to unmute yourself. If you wouldn't be interested to talk during the webinar, please let the organizers know using the chat function. Please note that the webinar will be recorded. Our presenters today are Alina Danshu from Sciences Po in Paris and Arifan Gregory, consultant from New Hampshire in the US. Simon Hodson from CoData will help administering the webinar tool and will moderate the question and answer session later on. I am Hilde Orten from NSD, Norwegian Center for Research Data. And now I give the word to Arifan to start the presentation. Arifan, please.
Good morning, everybody. Well, morning my time. I've been working with the DDI Alliance for a couple of decades now, and been dealing with metadata for all that time. And I think people have some obvious questions. When you work in the area of metadata, you hear these kind of questions a lot. You know, why is it so important? Isn't it just data about data? And shouldn't we really focus on the data instead of talking about metadata? And I guess those are fair questions. But when you hear the one, isn't it just data about data? That one especially is annoying because it is so much more than that, really. And it's true, it is data about data, but there's a lot to metadata, and we're going to get into that a little bit today. Alina, can we have the next slide, please? The truth is, if you care about data, you care about metadata. When people search for data, they don't type in 1962.437 because that wouldn't produce any meaningful result. They search for the information about the data they want, and that's metadata. Metadata is what allows you to discover data, to assess whether it's fit for purpose, to navigate collections of it. It allows you to understand it. Your machines need it to process and manage data, and ultimately, it's how data can be reused, integrated, organized. And if it sounds like I'm talking about fair here, that's because I am. If you want fair data, the metadata is what makes it fair. And the FAIR principles talk a lot about metadata. And when you start implementing FAIR, it becomes very central. Next slide, please, Alina. At the end of the day, the thing about metadata and why we're focused on it as the first webinar in this series is that it is the limiting factor. Your data is only ever as good as the metadata that you have that describes it. There's a tradition in research where small groups of people go off and collect some data and analyze it, and they publish it. And you know, everything you need to know is in the paper, and they don't worry about documenting it. And that's been a long-standing tradition in the research world, you know, depending on which domain you're in. But the reality is changing. You're seeing larger research projects cutting across organizational boundaries and domain boundaries even. We have grand challenges today like COVID, like climate change, and all of those bigger projects place a much stronger emphasis on good data management. And that means having good metadata. If you want to manage your data well and you want to use it well and share it, metadata is the key. So you have to understand that metadata is the limiting factor. Without good metadata, it doesn't matter how good your data is. Next slide, please, Alina. The term metadata can be confusing. It gets used a lot of different ways, and it means slightly different things in different domains. And really, DDI is in what we call the social, behavioral, and economic domain. And we get used a lot in official statistics, a bit in public health. And we have a perspective on that. You have to respect that other domains are going to see metadata differently. But we also need to have a shared understanding of metadata. And that means describing what each domain means when they say metadata so they can talk to each other, share ideas, share data. The DDI community has spent 20 years, more than 20 years, working with metadata, using it to manage data, implementing it in systems, and modeling it. And that is not the only perspective on metadata, but it's a mature one and a proven one. So really, we think that if people are going to understand what we're doing and maybe learn from it, maybe be able to use our standards or use our approaches and ideas, they should understand what the metadata, what we mean when we talk about metadata. So it's really the bedrock that we built all of our standards on, and we're trying to share that today. Next slide, please, Alina. My last word before I turn you over to Alina to go into this in a little more detail is that metadata can be complicated. And the reason that we're going to go into a lot of detail in this workshop is because although it is complicated, it's also worth understanding. That's how important it is. And on that note, I'm going to let Alina take you into the weeds a little bit. Alina.
Thank you, Arfan. So let's take a look at the topics of the next part of the presentation. So we'll begin with a quick look of the definition of metadata. Then we'll get a little bit philosophical, if I can say that, and speak about the difference between data and or metadata, their roles, their usage, and in the end, Arfan will bring up the subject of the management of metadata, and yeah, we'll end with that. So defining metadata. This is a great example, that a classical example used in metadata workshops. So an overview of metadata and their importance. I invite you to look at the picture of this tin on your screen, and what do you see? What is in it? Is it something you can have for dinner, for lunch, or breakfast, or is it food for you, maybe your pet? It might be paint, or maybe you are thinking to change the oil of your car, and this can be a tin oil. So without the metadata, and in this particular case, the label of this tin, you have no idea what's in there. So now you know. If you look at this thing here, you know what is in it, because obviously it has the label. You see both sides. So yeah, it was not oil, it was not cat food, it's chicken soup. So this is a great example for illustrating metadata that I did not invent, of course. I would have liked to, but I would like to give a shout out to Jane Fry from Carleton University in Canada. I don't know if she's there. She gave a great tutorial at the EDI Conference 2020, the European DDI Conference. So she inspired me a lot for giving these 2 slides. Thank you, Jane. And if you have the time, the tutorial I mentioned is on the DDI Alliance channel on YouTube. And if you don't know what I'm talking about, please leave a comment and I'll put the link in the chat after my presentation. So now let's bring this example into the data world, because I guess most of you come from this world. When you look at this screen, once again, you see some numbers. You can guess what some stand for, but still it's impossible for you to know what they are all for because you don't have the metadata. And with the metadata, yeah, it's a lot easier. So now, yeah, you know a lot of things. You see that we have here age in years as of last birthday, sex, weight in pounds, and all these are metadata. So yeah, I use a lot the word metadata. What does it mean anyway? So a little bit of semantics. So meta from the Greek meta is a prefix meaning, as you see on the screen, beyond, after, transcending. Metadata, so are descriptions or of informations about things. And I might add, no matter the support, paper or digital. So literally, metadata are beyond the things being described. So let's come back now to the numeric table example that I showed you. As Arafan said, it's very common to hear the definition of that metadata is just data about metadata, but as he said, it's so much more than this. So in the case of the numeric table example, metadata are the headings for the columns, the description of the values in each column. They describe the table and they describe the data in the cells. So people define it as data about data, but yeah, once again, it's so much more than this, because as you saw in the food can, metadata are what is written in the label or the can, but they describe the contents of the can too. So yeah, metadata is not just data about data. It may be about the data, like in the numeric table example, but it may be about some other things, like the food can. You should, yeah, all this requires a broad view of metadata, data about some resource. So an enhanced definition that we propose, that metadata are data intended to be used for describing some objects. So yeah, I spoke a lot of data or metadata. So what is it? Well, let's say it depends, but the main question you want to ask yourself here is, how do you intend to use the data? Because yeah, data are intended to measure, to record observations as part of research. For example, uh, let me speak about microdata. That is data used to represent a population. So here you have, your purpose is producing statistics, and administrative data used to manage a social program. Here you use data to monitor results, eligibility. So the primary purpose of the data is not to describe. This is the purpose of metadata. What data are intended to do is measure. So let's once again consider microdata or administrative data. So in microdata, for example, each respondent will answer a questionnaire. So the collected data are the description of each respondent. Some examples of administrative data. Well, you have the classical example, the census data. Then you might have medical records or other things like that, vital statistics or hospital discharge data. Sorry. So why aren't these metadata? So in each case, data describes some things, but survey responses are used to measure characteristics of a population, and administrative data are used to measure characteristics of the program participants. So metadata is a role also for data. Not all data are always metadata, but data are metadata when they are used that way. So most of the data can be used as metadata, and just to get things more complicated, sometimes data could be both metadata and data. It all depends on the perspective or on the usage. So same data, different perspective. So let me give you some examples just to maybe make things clearer. Maybe some of you know the standard Dublin core. So the Dublin core metadata example is going to be my first example. So what I remembered while preparing for this presentation, and maybe all of you know it, but I'll say it anyway, is that the Dublin from Dublin core refers to Dublin, Ohio, USA, where this metadata schema comes from. So the Dublin core metadata schema is, I guess, one of the most commonly used metadata standards. It originally had 15 elements, but now it has over 40. And yeah, let me give you some examples maybe of the 15, of the original 15. So contributor, coverage, creator, date, description, format. What is important to know also is that each Dublin core element is optional and may be repeated. So now it is the object of interest of this for the users of these metadata standards are very diverse, like museums. It can be used for describing paintings, pictures, documents, tool, not data. It maybe you have seen it in describing book libraries and things like that. A second example now, the telephone call example. It's a pretty classic one, I guess too. So let's say you call a friend. What the telephone company knows about you is who called whom. Was it you or was it your friend? Whether the connection was made or it failed. Did you actually speak to the friend? How long the call took? Still, they don't have the content. They normally don't have the content of each conversation. They don't know what you spoke about. Telephone data contains, so one number we used to call another. There's some subscriber information of the caller. They have the date, the time this occurred, connection, was it made or not, and how long the connection lasted. So what you can use as data here is the built network of calls. So nodes are considered phone numbers, subscribers, and the use as metadata is the part of the description of this particular phone call. So the role that the data plays here is crucial for making the distinction. And another example is the classification scheme example. So once again, we approach the data world. Possible definition of the classification scheme for those of you who don't know. We could say it's a description information for an arrangement or division of objects into groups that are based on common characteristics that these objects have. So for a classical classification scheme entry, so you'll think about concepts, codes, definitions, descriptions, relationships. You'll think about the data for a classification database. Also, if you want to build an N-cube or as an element of a dimension, you also think about data for the construction of a stratified sample. Maybe not all of you are from the statistical world, so a stratified sample is a type of sampling method in which that is used in statistics, in which the total population will be divided into smaller groups or strata to complete the sampling process. So the strata that I previously mentioned will be formed based on some common characteristic in the population data. If we think metadata now, the metadata for the user of a table as description or as a meaning of a cell, we'll think about stuff like that, or metadata for the user of data based on the stratified sample. So metadata, when you speak about metadata, it's also very important to speak about roles. So yeah, several metadata can have several roles and supports three main uses: discovery, understandability, and usage. If I think about discovery in the quantitative world, in quantitative data management, I come from that world, so it's easier for me to give you an example. So I automatically think about question banks, for example. For understandability, yeah, you'll think about the semantics of resources. And usage, well, it describes limits of reasonable use. For example, how was your questionnaire fielded to a certain population? And if we think about secondary data reuse, am I as a researcher interested in a database about, I don't know, students or retired people? So it's important to describe the limits of data. So above uses, there are also roles, and so variables apply in all three cases. It's also the case of the data sets and of the structures of data, but these are definitely not only roles. So let's speak about usage now. And yeah, let's speak about what we want to describe, because as I already explained, metadata may be used to describe data measures, but metadata describes. So you have a lot of examples here. Data variables, segments, questions, questionnaires, I don't know, disclosure control, data transformations. So once again, for the quantitative data management specialists like me, the description of variables, if I have to choose some examples, the description of variables is very important in what we put behind this. When I describe a variable, well, I have the reader question, the universe, who the question was addressed to. I'll also have the interviewer instructions and even some notes, like the recoding syntax that was eventually used to recode data, so that the people reusing this data have all the information they need to in order to understand the data. Also, code lists are very important to understand data. Response domains. You can also describe instruments using metadata. Did you use a questionnaire? Did you use an interview grid? Yeah, you can also describe segments for the qualitative research domain. Describing these groups of people with similar qualities used in qualitative research is very important. So yeah, I gave you several examples, but there is so much more. So we'll finish this section by speaking about three use levels of metadata. I'll begin with the simple one, then the enhanced, and the advanced. So simple metadata allows you to describe and compare. So it allows you to, I don't know, document descriptions of statistical objects, and also to provide means of comparisons across several things like objects, programs, experiments, studies. You have a whole list there. Then enhanced metadata, that they will allow you to create more complex descriptions, and the notion of reuse is introduced here, and it's very important. There's also the notion of machine readable and machine understandable metadata. So in this way, you enter once, you reuse several times. So you avoid using long prose documents. You implement machine readable formats like XML, JSON. So you strive towards metadata-driven processing, and it's very important. And you finish you end up by having machine actionable metadata. You also promote the concept management, where concepts are used, where they can be used at several levels. You can link similar meanings, and also you have here for the definitions, you can use the principle defined by all these people that are smarter than me, and you have here a lot of ISO standards and norms for doing this. So management of metadata, very important. So metadata are data, as already stated. Metadata can be managed in a database. You can have metadata repositories that are databases of metadata, and it's common practice for metadata to be stored in data repositories. So you also can have relational object-oriented graphs, networks, other supports for metadata, if I can say that in that way. But all of this depends on several factors that are important, like available software, the current expertise of your team. What are the other systems that are available? Of course, the time frame, the costs, the risks. If I were to give an example from my experience, we have a Dataverse repository, for example. I would not advise anyone to implement a Dataverse repository in their institution without having let's say IT resources, and especially an IT administrator, a very good one, because maybe the first implementation can work well, but then you have updates that you want to do. So you need this knowledge, you need this expertise. Once again, it's just an example that is based on my experience. So let's take a closer look now at the benefits of managed metadata. Well, there's a lot of benefits. You'll get more consistency in the production and dissemination of data. You'll have more comparable data. You'll have more understandable data, and you'll have more fair data. And everybody's speaking about fair now. It's very important. It allows you also to assess and ensure data quality. And in terms of organizational efficiency, well, it will allow you to reuse the metadata assets to better design, implement, and execute your processes, your business management processes. And you might be interested in increasing automation in your organization and avoid all this manual repetitive work. So what have we seen until now? The definition of metadata, so data intended to be used for describing some objects. We have compared metadata with data. When are data metadata? Well, we saw that it depends. We spoke about the roles of metadata, so it can be used for multiple purposes, about the uses of metadata, 3 uses: human readable documentation, sharing metadata, and reusable description, and concept management and machine readable metadata, so enter once, reuse several times. And we finished with management metadata that are data, so it's important to manage them similarly. So I'll let Erfan speak now about DDI products and evolution, their evolution.
Thanks, Helena. What I want to go through now is a little bit of what DDI has done with some of these ideas. And if you can go to the first slide, Helena, the next one. So DDI has been working for more than 2 decades on metadata used for research data management. And Alina described a lot of very open-ended things, a lot of topics, a lot of more philosophical questions. That is not where DDI came from, honestly. It was always a sort of bottom-up initiative where people who needed to manage data, and primarily data archives in the first instance, but with an increasing scope into the world of data production, built the tools they needed. The understanding of metadata in that community has evolved over time, and I want to look at that a little bit. So the DDI Alliance now has a suite of products that has grown in scope and continues to grow, and I want to characterize that. One more. Alina, next there, thank you. There are 3 basic specifications that we're talking about here. Alina, can you go back to the preceding slide, please? Thank you. The first one is a thing called DDI-Codebook, and the term codebook may or may not be familiar to you. It's what we call a data dictionary. I'll talk a little bit more about that, but if you hear people talking about DDI 1 or 1.2 or 2.5, that is the initial product that the DDI Alliance came out with, and it's been in widespread use for a long time. Very, very common in a lot of different implementations. DDI-Lifecycle was the next one, and that was a more complex specification. I'll talk a bit about that. And that has not been around as long, but the 3 series is really what DDI-Lifecycle is. And then there is an up-and-coming product called DDI Cross-Domain Integration, or DDI-CDI. And that is a different kind of metadata standard that will be released, we're hoping, this summer. So if you can go to the next slide, Alina. DDI Codebook was a very simple thing in concept. If people know what a data dictionary is, especially in tools like Stata or SPSS or SAS, you have a listing of the variables in your data set and a description of those variables with things like how are they represented, what codes might be used in the data set, what do those codes mean. It's a fairly simple definitional document that people use to understand data. And the term codebook is quite common in the social sciences. You're talking about what are termed rectangular files. That is, each row in a table is one unit, typically a person or a household, and each column is a variable. And that's the sort of data that is common in social science. In DDI Codebook, they wanted to create an XML version of that document, and that's what they did. And it's quite detailed. There are a few hundred metadata fields. Now, Alina told you earlier about Dublin Core, which has now 40. DDI is an order of magnitude more detailed than something like Dublin Core because it needs to support the management of things at a more granular level. And that's true of all of these specs. Dublin Core is supported in DDI Codebook, and it literally reused in DDI Codebook. And there's a lot of descriptive study level metadata. That is, things about the methodology for the entire study, who funded it, who conducted the research, lots and lots of information about the entire data set as a whole. But there's also a lot of machine actionable or at least machine readable metadata about the specific variables themselves. So it covers the entire scope of that kind of a codebook document. It has some limitations though. Because DDI Codebook came out of the archiving world, they basically had a work process where they were given a data set and they needed to disseminate it for reuse. So they had all of the information right up front. It describes data after the fact at a single point in time. One data set is deposited, described, and disseminated. And that can be kind of limiting if you're not a data archive or a data disseminator. Can we go to the next slide, please, Elena? DDI-Lifecycle was created in response to that requirement. People who were producing data in an ongoing way, a lot of large longitudinal research and data collection efforts needed something that didn't just describe one wave of data collection, but multiple waves. And that's not just longitudinal, but repeat cross-sectional. And the idea here is that if you can describe the relationships between data sets, you open the door to a lot of things. And so where DDI Codebook had a very simple description of a document presentation of metadata, DDI Lifecycle becomes something much bigger and more complicated. You want to be able to compare and harmonize data between waves and from different sources. There's a lot more emphasis on the data collection, because as you produce data, you start with the design of a collection and go through the life cycle. I'll show you that in a second. And so we ended up with a much bigger standard with a lot more metadata and this idea of comparison and reuse, which of the metadata itself, not just of the data. So it's a more complicated subject, but it's a very central one. If I want to compare two studies and I have two similar variables or two identical variables, that's a point of comparison between them, and a meaningful one. It's something I can use to do a join. If my geographies are the same, if the time aligns in the right ways, those are important when you're merging data sets and combining data sets. And so those kinds of things are captured much better in DDI Lifecycle. The focus is still very much on rectangular data, and the encoding of the standard is very much using XML as a technology. Now that's probably the most common technology approach around metadata in the social sciences, but in the modern day and age, that's not really the only one that you'll encounter. I'd like to show you the lifecycle diagram. Can you go to the next slide, Elena? This was the original picture that the DDI Alliance put together, and it's a little faded because it's been around for a lot of years now, since 2000, I don't know, 5 or something. But this was distilled from about 30 other lifecycle diagrams used in different implementations. And basically it lays out the life course of data. So someone has an idea about collecting data, and then they'll conduct that collection. And DDI Lifecycle lets you describe in machine actionable detail, in a very granular way, the metadata that makes up a survey instrument, for instance, and how that survey can be answered and the flows through it, and how that results in data, in a raw kind of data that is processed to produce an analysis-ready data set. And the processing itself can be described. And you might put that analysis data set in a data archive. It will be distributed. It will be discovered. It will be further analyzed or reused. And there's a lot of reuse in this picture, probably not enough repurposing arrows, if you will. But each of these stages can see different versions of the same metadata. The concepts I set out to study are the concepts that end up in my analysis data set, but they might have changed a little bit as this life cycle took its course. So you can understand that DDI Lifecycle is far more than a description of what's in a data file. It becomes a description of the life of data throughout a research project, if you will. Next slide, please. There's a big change here. DDI Codebook let you talk about the definitions of variables if you wanted. It was optional. I could say I'm using concepts. So I have a concept of age, which is an integer that was your age on your last birthday, a whole number. And it can define quite sophisticated concepts. They aren't hard-coded into the standard. They can be whatever concepts you want to use, but they're not required. When you get into DDI Lifecycle, you begin to realize that concepts are the fundamental metadata that allows you to compare data sets from different sources and across waves of a study. And so they became a much more important formal construct in the metadata. They get used by variables, yes. They also get used by the categories, the meanings you find in things like code lists and classifications. They get used by units and populations and universes. So how do you describe the set of people or things that you're studying? How are those defined? What are the distinctions you make between different groups within that population? All of those things are tied back to formal definitions of concepts. And that becomes incredibly important in the semantic world, where SCOS, if you're familiar with semantic technology, SCOS is the most used RDF vocabulary for a very good reason. When you start trying to navigate things in the wide world of data, you need to understand the concepts. They become the touch points where you can begin to join things together and understand them together. And so I really want to highlight the fact that of all of the metadata things that Alina presented to you, the concepts become very primary. And they become the basis of mapping between data sets. Can you go to the next slide, Alina? Which brings us to what we have today in production. And this is the DDI cross-domain integration specification. Both DDI Codebook and DDI Lifecycle were very much domain standards for fine-grained and machine actionable metadata in the social sciences. The thing is that the social sciences, like a lot of domains, are starting to use different kinds of data coming from different places, and a lot of those places are outside the home domains. We're reusing data from climatologists. Like, that data is not familiar to a social scientist. And when you start crossing those kinds of domain boundaries, you need a way of understanding their data that goes beyond what they might document for themselves. And it's certainly not necessarily similar to the data that you're used to working with. What we see are a lot of different kinds of data, and what is in the DDI cross-domain integration specification is a set of metadata that extends DDI Codebook and DDI Lifecycle, but in fact could be used standalone or with any other domain standard that gives you granular metadata about your data. But it adds the information you need to understand how different types of data might relate to what you have. We've divided this into 4 basic types. We have the traditional wide rectangular data files described, but in addition to that, we have long and sensor data, so event data. Think of the streaming data is very different structurally from rectangular data. We have the ability now to describe multidimensional data, that is data cubes, which Alina mentioned briefly, but that is very common in like the world of official statistics. A lot of aggregate data is dealt with in a multidimensional fashion, and that requires additional metadata, a little different data structure. With the advent of big data technology and NoSQL technology, we have this idea of key value data. So you have data lakes full of data points with identifiers, and that's all you know about them. And you need to be able to navigate that very loose structure and associate it with more formal structures that you have inside of things like statistical packages. So all of that kind of metadata and the ability to map between the structures is part of DDI-CDI. So we can bring data in from other domains and have it make sense with what we understand. There's also a strong emphasis on data provenance. So you have processing descriptions and a lot of information about how data is transformed in order to be reused. It's harmonized, it's integrated. And again, the concepts are the key thing here. What falls out of all of that descriptive information that you need to reuse data across domain boundaries and organizational boundaries is a strong focus on the individual data point, because that's the thing that doesn't change. It gets repackaged in different ways in different applications, but the data itself doesn't change at the most granular level. It is what it is. It's measured and described in a certain way, but it can appear in different data structures at different points in a life cycle. So the focus in DDI-CDI is very much on the individual data points, the datums we call them. The other big change with DDI-CDI is that we're no longer just an XML standard. The primary expression of the standard is a formal UML model, and we have an XML expression, But the idea is that that UML model could be bound into a broad range of technology platforms, so that we're not restricted to what the technology we use in the social sciences domain is. This is a tool that could be used basically in any domain as a result of that. Anyone who can understand a formal UML model. So that's basically the third installment in the product suite, if you will. And you can see here that we have this sort of evolution of the idea of metadata as we move forward. Next slide, Alina. This is really I don't know where to finish this presentation other than to say that what we've learned in 20 years is that the formal encoding of metadata and the machine actionability of metadata are increasingly important. And so we have a couple of addresses here, an email and a contact form that you could use to get a hold of us if you want to learn more about DDI specifically. We will be doing more webinars in this series focusing on all of the standards that I've mentioned. But there's an idea of metadata that is common across them, and that's really what we've tried to present today. So I think with that, I think we can open the floor up for questions.
Thank you very much, Arafan and Alina, for those presentations. I'm Simon Hodson, Executive Director of Codata, and I'll be facilitating the question and answer part of this webinar. There's been some fantastic questions so far already in the tool. Please keep them coming. I'll start with a couple of questions for clarification. So Olga Churakova asks, what's the main difference between a README file and metadata, data about data description? So Alina, would you like to take that one and clarify the difference between metadata and a README file?
I'm not sure to understand it correctly, but I'll try to answer. When I think about metadata, I think like Irfan mentioned about standards, about tools, XML files. A README file will just stay on your computer forever, and at a certain point you'll just forget it. You'll forget it's there. Properly managed metadata, I think the distinction is important, are there to stay. And even if your tool, this is what happened to us with Nestor, for example, it's a tool for managing metadata. At a certain point, it became obsolete, and we had to take our metadata and put it elsewhere, but we could do that because we used a standard, and we had XMLs that we could just get out of one tool and put it in another. It would have been a lot more difficult to do that if we just had README files or PDF files. I hope it answers the question.
I can make it difficult, Alina, if you like.
No.
Because README files are, they can be metadata. You can put all the metadata you want in a README file.
Of course.
Because a README file can be whatever it contains. It's just text. The problem with it is what you were getting at, though, Alina, is that it's not structured, and you can't predict what's in it, and that's what makes it difficult to use. You know, and I think that's an important difference, is that managed metadata is predictable, and it is structured, and that's something that you don't get in a PDF, and you don't get in a README file.
Thanks, Arafan. Yes, I mean, I think that's clarified that issue. Jessica Hrudi says, maybe a dumb question, to which I'll respond, there are no dumb questions in this sort of context. What is an N-cube? Please clarify for Jessica what an N-cube is.
I think I'll let Irfan answer that one. He'll probably answer better than I do.
if you're familiar with, there are certain kinds of systems that create multi-dimensional, it's called a cube because people imagine an X, a Y, and a Z axis in a three-dimensional cube. Multi-dimensional data cubes take many axes, as many as 20 or 30 sometimes. And each axis is termed a dimension. And an N cube is shorthand for a multi-dimensional, like an OLAP cube, where you are able to address bits of data by saying this is a certain age, a certain gender, certain education level, certain geography. And those would be 4 dimensions describing a particular observation in this notional cube, quote, cube structure. So really it's just shorthand for a matrix, a multidimensional matrix used to process and manage data.
For example, we had an N cube in our database, in our catalog. We had financial data for the United States by state and year, and you could select, like, I want financial data for this state and for this year. Yeah, it's like that.
It's like table, only more complicated and more computable, if you will.
Yeah.
Okay, thank you. Another question on similar lines before I move on to a more complex question. Can something, so this is from Mariana Glavica, and she asks, can something be called metadata if it's not machine readable and if it's not structured in some way?
I'm sorry, I didn't catch the first part of the.
So can something be called metadata if A, it is not machine readable, and B, it is not structured in some way?
Yeah, of course, I would definitely say yes. It's not properly managed, in my opinion, but it's metadata. Yeah.
I would draw a simple picture there, Simon, which is that there is a sort of range of things. Metadata is information about data, and it can be anything, and it certainly can be unstructured. You then have a class of descriptive metadata that is what we call narrative metadata, that is really human readable text documentation, and it's nice to have that be machine readable so you can put it on the web and stuff. That's different than machine actionable metadata, which requires that it be structured and much more formal and designed in a certain way. So I think it's important to understand that there are different kinds of metadata going from the unstructured human readable through to the completely structured machine readable. But there's a whole sort of range of things that can be in between those points.
Sorry for the pause, but I'm also typing these answers into the chat machine. Okay, so the next question, I found this very interesting, and we may ask the questions to unmute and I think this, if necessary, and I think this would be good to be directed towards Arafan. So Michael Hiremans says, let's say I have created a data set. For example, a time series of temperature, humidity, air pressure, and maybe some other parameters at a certain location. How do you suggest I create metadata for this data set? Just write manually an XML file, or are there more automatic ways of doing this? For example, are there XML generators?
Well, there are a number of questions rolled up in that, because depending on how you're processing that data, if you can capture it in the tools you use to create the data, that is a very good thing. And that is the best practice, I would say, in modern approaches. And most people don't end up typing XML in a text editor anymore. It's going to depend a little bit on what you're doing. If I had to produce a Dublin core, I might do that in a text editor. It's easy. if I had to produce a DDI lifecycle file, I would use a tool, and there are a number of them, for creating the file manually, or preferably capturing it, mining it is the term, out of things like the statistical packages, at least to the greatest extent possible. So you give an example data file, and I'm hearing that this is a multidimensional thing. I have observations, and then I have a series of what you're describing as parameters that are probably dimensions. If I want to do it as a multidimensional structure, those might be entries in a stream of data where I have a set of context values describing a measurement. Either way, I would want to capture as much of that as I could. Typing it by hand is going to be expensive. It's certainly possible, but that's going to depend a lot on what metadata model you want to use and how detailed you want that recording to be. I think there will be topics in this webinar series that address the specific tools that we have around DDI in future. But again, most of the systems that I've worked on would try to capture that metadata at the source and try to do it programmatically. Is that a good answer? Is that enough of an answer?
I think that possibly is. I would also add it that, you know, those sort of examples from the environmental sciences, for example, the metadata specifications that will be used there would be different, and you know, it's important to understand both the instrumentations, the automated capture of metadata, and the sort of standards that will be used for those particular values and data types. So there's a question here which is intriguing. Ricardo Braukman asks, and this is for Arafan as well, is there a tool available that individuals can use to create DDI-CDI themselves? So this involves a discussion of the DDI-CDI development process. Arafan, over to you.
Well, no, not yet. We have implemented be aware that the specification is not in production yet, and that is probably the main reason. The test implementations that we did during development mostly involved capturing the metadata as an artifact of the data production or integration. So we were looking at tools like, there's an ETL platform called Pentaho, and we were using that to capture a lot of the metadata that we were using as one of our sort of test implementations. Another one was looking at R and working with metadata capture out of R and the kinds of R libraries you need, not just to work with the data, but to actually begin to capture the metadata associated with it. There will be tools, but I'm not sure there's ever going to be a sit down in front of the editor and write it kind of a tool for CDI, because it's really designed to be mined out of other statistical packages and other tools. You could create such a thing, and it may be that they will. We're talking now to Dataverse about how they might implement something that would mine as much metadata as they could get out of like a Stata file, and then have an interface for enhancing that to produce the CDI for it. Those are things we're exploring. They don't exist yet, and I don't want to mislead you. But we are certainly looking at what those kinds of tools would be like. I think that's still kind of a bit of an open question.
Thank you, Arafan. And just to clarify, the production release for DDI-CDI is scheduled for June or a bit later?
June is the target. There's a bit of an unknown there because it has to go through a quality control process, so it might be a bit later than that. What we're really saying is summer this year. I would imagine June or July is a realistic time frame. Okay,
thanks, Arafan. So there's some great questions here. I'm going to carry on working through them. Cyril Hoyder says he's got a question for Alina Donchu about metadata stored in repositories. How does it work? Do you have examples? And I think this was referring to, Alina mentioned metadata stores separate from repositories, but perhaps it's in a sort of a classical data repository where you might have a metadata file and then a link to the data file itself. Alina, over to you.
So I gave an example in the during the presentation, Dataverse. For example, we have metadata in that Dataverse. We do not have data yet there. We intend to, but it's not the case yet. So what I was saying in the presentation is that you can have metadata separately from the data. What we have is a link. You can download data here, and there's a link to the platform where data actually is. And yeah, of course, today all of these platforms like communicate between them. There's a harvesting process, so metadata can be in several places, data just in one place.
Okay, thank you, Alina. Cyril, was that a did that answer what you wanted to hear? I've just unmuted if you want to follow up with that question.
Yeah, that's fine. Thank you.
Okay, thanks. So working down from Nikolai Constantinescu, is DDI pushing a specific vocabulary and a DSL, domain-specific language? Is DDI RDF compliant? Who wants to take that?
I can begin answering about vocabularies. Maybe Erhan, if you want to speak about RDF. Yeah, the DDI Alliance manages controlled vocabularies, its own controlled vocabularies, and there's also, of course, the CESDA vocabularies. So yes, DDI L, for example, the DDI-Lifecycle that Erhan mentioned, and DDI-Codebook also. You have control vocabularies that are recommended. They are not mandatory, but recommended.
Yeah, I'd like to follow up what you've said, Alina. I think it's important to note that there are a set of controlled vocabularies that are recommended as a convenience to the DDI community, but they're pretty specific to the domain. DDI does not use any given vocabulary. The intention is that you can configure any vocabulary whatsoever to work within DDI, and that's one of its strengths.
Yep.
So sometimes it's good to have agreement, but sometimes it's very good to be able to take whatever you've given and describe it, and so it can do both of those things. There are RDF vocabularies that have come out of DDI based on our metadata model. The production one right now is a thing called XCOS, which is an extension of SCOS for describing statistical classifications. There's another one called DISCO, and I'm not sure if it's actually been released yet, but it's a data discovery vocabulary in RDF based on the DDI Lifecycle and DDI Codebook model. DDI CDI is designed to be implemented using things like JSON LD. So it's not that there is a single RDF expression of it. We expect people to use semantic technology around that model, and we're open to doing an RDF expression of it if that's necessary. I think the key thing to realize is that DDI looks at structure and describes structures, and the meaning is configurable. So it's designed to work with any vocabulary, and we recommend some, and those are useful, but you don't have to use them. And the key thing that we go into in detail is the structural aspects of data with whatever semantics you use. I think that's one of the most powerful things about the model, actually.
Okay, thank you. Thank you both. I was just struggling to keep up with the typing there. So what's next? So sorry, I'm just working down the. I'm trying to get some new questioners. This is an interesting question, though. So it's another question from Jessica Hude. Is there a dictionary somewhere for newbies about what the different terms within DDI mean? I found trying to work in Nestar and Collectica, I was struggling to figure out what I was supposed to enter in certain fields. So this is an explanatory dictionary which helps guide people through implementation of DDI.
I think I would answer with a question. What is your knowledge about DDI? Do you know this? Did you take a closer look at the standard before beginning with the tool? Because I know from my experience that I began with Nestar without looking at DDI, and it was really hard a long time ago.
So I've unmuted Jessica so that she can respond to that question. Jessica, if you unmute on your local machine, then you should be able to speak and explain the question a little bit more. Jessica, are you with us? Are you able to unmute? Yes, you're unmuted now, Jessica.
Maybe I could add a little to that.
Mm-hmm.
There is a glossary available on the DDI website, but that needs update. So that is a task that will be taken on later on. There you find some more definition. In addition, you find, apart from looking into the kind of structures and definition in the specification itself, there are some what you call DDI profile that is for life cycle, that explain different usages of the standard in XML, so you can see which parts people use for different purposes. That is also available from the website. And
sorry.
Yeah, and then you also have the manuals, user guides, and the kind of technical documents that also explain things a little in detail. So that can be useful to try to understand more. When it comes to the DDI CDI, that has a more thorough specification. So it is the different things it handles, and the examples are a little more detailed described in that one. And there are more practical examples also. Maybe you, Arafan, could add more regarding that.
Well, I think we'll see what comes out with DDI CDI, and we're trying to document that better. But if you're using Nestar, there is a place I would look. There is an organization called the International Household Survey Network, and they have a package of tools based on Nestar that they have been distributing to statistical agencies in the developing world. Among the things they give out is a manual for how to document surveys. And if I had to point people to one single place to learn how to use DDI, especially if they're working with Nestar, I would point them to the IHSN guide for documenting surveys. I think it's an incredibly well done piece of work, and a lot of people use it just as a basic how to use Nestar guide. And it's very much couched in terms that data managers and researchers can understand. So I would strongly recommend that document as a good starting point. because I think it is confusing and there isn't a really good up-to-date glossary at this point.
Okay.
And hopefully we'll fix that. I know they're working on that.
And maybe,
Yeah.
sorry,
Go ahead.
for Europeans, you know SESDA maybe more than people coming from other continents, but you have the SESDA metadata model that is pretty good also.
Yep.
Thank you both. So Jessica added in the chat, I don't think she was able to speak through her microphone, but she added, I did try to use the information that was on the website. Presumably the DDI website is overwhelming and confusing. So I think there's a recommendation there to Arafan and to Alina, perhaps just to gather together some of these guides that have been mentioned, the IHSN guide, for example, and provide those links. I'll move on to
Simon, I could just add a little to that.
Sure.
That in the training group there is a subgroup that is focusing on improving the website specifically for beginners. So that we are about to finalize that, and so there will be some tidy up of those pages, I hope, in the not too distant future. Thank you.
Thank you, Hilda. That's very useful. Right. So where was I going to go next with the? So to follow up on a previous question, I think this is about metadata creation, and this is a question from Kenan Direk. If you have a simple flat data file, is there an automated tool to generate DDI compliant metadata?
We already mentioned a lot of tools that generate DDI compliant metadata. As Arafan said, I think there will be a session that will be dedicated to this subject. But yeah, you have even the participants mentioned Nestor, Collectica, Dataverse. I don't know if you want to add some of the tools, Arafan and Hilde.
Yeah, there are a number of approaches, and you say a simple flat data file, but there are a lot of questions there because the basic way that DDI deals with data is as ASCII, flat ASCII files, common CSV or space delimited. There are different ways of doing flat files. Sometimes, if those are used in certain of the statistical packages, there are very good tools for mining DDI information out of them. And most of the tools that Alina mentioned, like Collectica, like to some extent Nestor, have the ability to do that. There's another one. There's a utility package for working with statistical files that will produce DDI stats. Oh God, I forget the name of it. Hilda, do you know? But there are a number of tools that will mine the metadata out depending on how it's formatted. And the problem with a flat file is that it can have metadata in it in a whole bunch of different ways. So there's no yes or no answer to that question. Oh God, why can't I remember the name of the utility? But anyway, a lot of the stats packages are able to do that. I would suggest, if you are interested in pursuing that with a specific example, that you contact us using the contact form or email here, and we could pursue that a little further. We work with people who are very good at metadata mining that we could probably put you in contact with or get some additional information if you have a specific case in mind. So.
Okay, thanks, Arafan. So question
sorry, Simon, stats transfer was the name of the package.
Right.
Senior moment.
Thanks. Okay, so there is that invitation to use the contact email and contact form, which is still being shown as part of the presentation, to contact the presenters about the such specific questions. So a question from Dorian Heuser. How relevant are metadata standards like DDI for individual researchers who want to share research data, as opposed to systems that use it without users explicitly seeing it? So for example, how would individual researchers use the DDI standard in their research project?
So I work in a university, and for auto archiving. To allow researchers to auto archive their data, yeah, I already mentioned it a lot of times. We use a Dataverse platform, but there are a lot of other tools available, I guess. I saw in the questions that somebody mentioned Collectica for researchers. I would, for example, just to give an example, I would say it's too complex, maybe.
Alina, there was a paper that came out of GASIS. It's a Social Sciences Institute in Germany, and one of the Leibniz Institutes. And some of the people there working at the archive have written a paper. It turns out that the chair of the training group that we all belong to, Anya Perry, was one of the authors of that paper. And I'm not sure if it's been published yet. It would be worth looking for. But she and some other people wrote a paper about that exact topic, is what can DDI do for an individual researcher or a small group of researchers. What you see in Collectica, Alina, and I think it's good to mention that, is something that lets you document your data as you go, and then do things like produce a website that is your own documentation to your own data in its current state. And that can be very useful, especially sharing with colleagues who want to look at your data and know what it is. And so you have a pretty slick, useful documentation right there of your data as you work with it and as you transform it. There are definitely applications. Usually that comes within some sort of a research environment, though. And there has to be, it's not just like DDI is automatically good for individual researchers. You have to do something useful with it and have the tools to do that.
Yeah, I maybe would recommend Collectica for Excel. I know people from my institution are using it.
Yep.
And it's free now, right?
Most people, if you work in Excel as a common sort of format for documenting data or for the data itself, that is really useful, Alina. I think there are some tools out there, and it a little bit depends on exactly what you're doing. But
okay, but the point being that there is a use case and there are tools which would allow individual researchers or small groups to effectively use the DDI specifications. It's not just something that's for large data production for data centers, data repositories.
No. Yeah, you're right.
Okay, I mean, I think that was the question. That was the issue that the questioner was driving at. Another question relating to Dataverse, but I don't think this has been covered completely. You mentioned, so this is from Ricardo Braukmann. You mentioned Dataverse a few times. Can you talk a little bit more about Dataverse and DDI? Are there ways of getting DDI codebook or lifecycle metadata out of Dataverse, in particular for variable information? I think that last clause is interesting.
I think for the variable,
you want to do this one?
I was going to give it to you. I think for the variable information, it's work in progress, and yeah, Erfan will tell you more about it.
Yeah, there have been some really interesting demos done. If you're familiar with the Scholars Portal, it's at University of Toronto. It's Canadian University. They use Dataverse, and they have done a lot of work with Dataverse to capture variable level metadata. I don't know that that's in their production version yet.
It's not far.
There is a lot of discussion in the Dataverse community in their development meetings. They're currently speccing out additional functionality for better leveraging variable level metadata within Dataverse, including automated capture. And they already have some ability to mine things like statistical package files and produce DDI codebook. There is a company that called Metadata Technology North America that did a demo. If you go to their website, you might be able to find a link to it, where they actually did a demo based on Dataverse, where they have a set of tools that mined metadata out of statistical package files and then put it into Dataverse alongside the data files. But I think that that's going to be a generic feature of Dataverse in the fairly near future. Again, if you want to contact us, we can put you in contact with the people who are doing that work and give you a better picture of the current state of play. But as you say, Alina, I think this is absolutely happening and happening soon is my impression.
Thanks, Arthur, that's very useful. So there's a few more questions. We're getting up to the 90 minutes, but I think this is a particularly interesting one from Libby Bishop. Hi, Libby. It's been a while. Libby says, I advise other data archives, and I'm asking a question not about metadata per se, but about its business value. So a more generalized question, what arguments would you offer to archive directors to defend spending resources, staff time and budget to sustain and improve metadata activities? So back to that more general question, what is the value, the business value of metadata? Why is it important, and which should we spend effort on it?
Oh, Simon. I want to talk about my favorite paper, Simon. Is that okay?
Go ahead.
PricewaterhouseCoopers was hired by the European Commission to do a document on the cost of unfair data in Europe. And they not only did they mention DDI by name in their analysis, which made me feel really good. It was only in a footnote, but they actually gave a figure which said that as much as 80% of the effort of a research project went in to assembling the data into a form where it could be analyzed. 80%. Now, that isn't talking necessarily specifically about an archive's costs, but when you consider that the job of an archive is to provide the user with the information and the data needed to reuse the data, if you have good documentation, you're diminishing that 80% figure down to something reasonable. If you have no documentation or bad documentation, then those costs are being passed along to the researchers. And if an archive takes seriously their mission to support research, then you should take a look at the PricewaterhouseCoopers analysis, because there's a lot of numbers in there that might allow you to come up with a better handle for how much of that cost an archive could absorb by having good documentation in order to make its holdings more usable and more broadly useful to researchers. So I think there's a huge business case to be made here. I'm not sure anybody's done that particular case, but there is information out there you could use to make one for sure.
Thanks, Arafan. Maybe we'll ask Libby to respond to that. Just let me. Try and find her to unmute her. She may have. I'm not seeing her there. She may have left the webinar because we are getting close to time. Here's a question for Alina, again on the subject of Dataverse, from Tara Cook. Have you considered suggesting Nakala, which I assume is a project or a technology, to your researchers, which is a storage tool, sorry, it's explained, a storage tool created by Humanum in France, similar to Dataverse, each item is assigned a DOI. Are you aware of this tool?
Yeah, and I think some are already using it, and they are also using other tools of Humanum. We ourselves at the CTSP are using, for example, other tools. So yes, definitely yes.
Okay, thanks. For some reason, I couldn't see Libby on the list, but I'm going to unmute her now. Libby, do you want to respond and discuss Arafan's response and your question any further?
No,
You're
hello,
unmuted
both.
now.
Good to hear and see, hear people anyway. No, thanks. That's a brilliant answer, Arifan. Just the kind of thing I was looking for, and definitely is both the source and the kind of information that will persuade heads of archives and repositories in a way that other things won't, like the actual value of metadata. Anyway, thank you. Of course, if you can just provide the link or way to get to the paper, that would be great. Thanks.
We'll dig that out, Libby. It is, like you say, a very persuasive thing. I love the fact that they did that report. It's really good. But yeah.
Thanks.
Okay, thanks. We're on the hour and a half. There are a couple more questions. What do colleagues want me to do? Some people have had to leave. Shall I pick up some of the questions, or shall we wrap up there? We can answer any questions by email as well, because we'll save this question file.
Both ways are okay for me.
Okay. Well, let's take a couple more. There seem to be a couple more. So this is from Nicolae Constantinescu again. What data structures do you use, data structures or metadata specifications perhaps, for keeping track with versioning?
Do you want me to talk about that, Alina?
Yeah, if you want.
Because it is an incredibly important topic when it comes to management, obviously. Now, there is a sophisticated approach to versioning in DDI, which is, I'll try to lay it out. There are, first off, versions on two different things. You version the data itself. You also version the metadata. That is, the metadata record is also managed as a versionable thing. There is, in DDI-Lifecycle, a quite sophisticated mechanism for managing versioning, which includes the maintenance agency, the major version, minor version, and then the IDs of specific things. And the overall complete identification of an item is all of that. It's based on all of that information set. There is also an ability in DDI Lifecycle and DDI CDI to associate the formal structured versioning and identification scheme with an external version and identification scheme, and places where you can connect the versioning policies of data and of metadata both to those to the files, so both to the metadata and the data, but primarily to the data. So versioning is a super important topic. We recommend any one approach, but I think if you're serious about data management, versioning is a central concern. The attempt in DDI is to accommodate the different schemes that people have. Within DDI CDI, there's also a lot of a pretty well-developed structure you can use if it's convenient for you. Sorry, that's not a simple answer. It's not a simple topic. So we don't say you must do this thing or that thing. We try to support the different ways that we see people who are serious about versioning use in their own systems, in their own archives, in their own production systems.
Thanks, Arifan. I think so far there's only one more question. It's really a little bit more of a comment, but I'll throw it out there, see whether you'd like to respond. Adrian Dusa suggests that I think this should be raised more and more often. If big data is important, then big metadata is even more important. How would you respond to that assertion?
I would say that Adrian is always right. Sorry.
Alina, he's not always right, trust me, but he's usually right. What I would say, Adrian, is, and there was a very interesting article that you know Akim Vakaro, he's involved in DDI. He pointed us recently to an article about the amount of effort that people writing artificial intelligence applications spend trying to recreate or find metadata for the data that they're dealing with. And I think big data suffers massively from a dearth of useful metadata. I think that there's a huge cost associated with that people, in the excitement of having this computing power and this ability to have these massive databases, gets a little bit lost in the shuffle. I think that's a super important topic. And I think that there's a growing awareness that the metadata is also necessary and maybe even more critical in big data applications, in machine learning, in natural language processing. And for a while, I think people didn't wanted to pretend that you didn't have to worry about the metadata anymore. I think that's starting to change. That's the sense I get. Again, I would encourage you to ask Akim about it, and he probably has better specific references to give you than I would. But I think it's a very good point.
So we might follow up with that reference and some comments.
Yeah.
Okay, that's great. Skimming through, I think all the substantive questions have now been covered. And I think the only gaps in the question tool are sort of comments or little follow-up which to particular questions which have already been covered. So thank you very much to all the participants for that engagement with the presentation and those interesting questions. I hope they've all been answered, and we will look through the question. We'll download the question tool and follow up on any specifics with references. And I'll hand back to Hilda, I think, to close the webinar.
Okay, thank you very much, everybody, for attending this webinar and for the nice and interesting discussion. We are so happy to receive so many contributions, and many important points have been raised by you all. As I said in the introduction, this is the first webinar in a series, and there will be in 4 to 6 weeks a webinar about DDI and FAIR. That is the next topic. We will also provide in the not too distant future a kind of list of the following webinars, but it is also a little bit up to you users what you would find interesting. So please contact us at the contact address if you have some topics you would like us to focus on. That would also be great. And with this, I just want to thank you all for joining, and I hope you will come back to us at our next events. Thank you very much, and goodbye.